Right. Okay, so the complex number z has a modulus of 2 root 3 and an argument of minus a third of pi. Giving your answer in the form x plus I y, where x and y are exact real numbers, and showing clearly how you obtain them, find z. And they only gave you quite a small box. I felt it was a bit stingy, the box that they gave you for this. So what we're looking at, remember we're thinking here about some number. That angle is pi by 3. Now I am going to get myself a little bit mixed up about the minus signs in here, but we'll work it all out in the end. We know that if it's minus a third of pi, that we're going to end up with a positive x and a negative y, aren't we? Because it's that kind of orientation. So as long as we sort that out at the end, this length is 2 root 3, this is x, and this is y. So let's work out where we go from there. We know various things. We know that, well, you can almost do it with the, go straight into the sine and cos. I did it a bit more formally. I said Pythagoras' theorem tells me x squared plus y squared is 2 root 3. That's one equation to start with. I also know that tan of pi by 3, tan of that angle, is opposite over adjacent. So that is y over x. Now tan pi by 3 is, what is it? I can't remember. Root 3. That's right, isn't it? Tan pi by 3 is root 3. So we've got y is root 3x. Now actually, I know I'm getting mixed up with the minuses, and I'll work it all out. It's kind of, you could say it's minus root 3x at that point, couldn't you? I'm going to sub that into this equation to say, therefore, that x squared plus 3x squared is, that's a squared, isn't it? Is 2 root 3 squared, because it's Pythagoras' theorem. That's one of those things that on the video somebody's going to comment, somebody's going to watch the first 15 seconds of the video and then leave a comment. No,
I think you should start it from the beginning.
I'm not going to start, it's fine, it's all alright. So we get 4x squared is 12, 4 times root 3 squared would be 12. X squared is 3, so x is plus or minus root 3. Except we know, don't we, that because this is positive, because that is minus pi by 3, that x must be a positive number. So x is root 3, and if x is root 3, y, root 3 times root 3 gives us 3. So the number was 3 minus root 3. Now I've put that the wrong way around. Brilliant. Root 3 minus 3i, and that's our number. Okay, notice that when you write your complex number at the end of it, it needed that, didn't it? It needed it in the form x plus iy. So it's not enough just to say x equals y equals. It's not enough to write it in coordinates. It had to be in that form in order to get credit for it. So that was the number z. Then part 2 says, find 1 over z star minus 5i all squared. And this is, it's just, I don't like this question because it's just kind of untidy, lots of algebra to do. We're going to do 1 over z star minus 5i all squared. So let's think a little bit about where they're giving the marks for here. Z star appears in there. So clearly there's going to be a mark for recognising that the complex conjugate of z is going to involve you changing a minus to a plus in the middle of your number, for the imaginary part of your number. So that's the first thing. We need to work out z star minus 5i, because we're going to square that in a minute. That is root 3 plus 3i minus 5i, which is root 3 minus 2i. So that's the thing that's on the bottom. That's the thing that is going to be squared. So z star minus 5i squared is root 3 minus 2i times root 3 minus 2i. Just carefully kind of bring all of this together. That gives me root 3 times root 3 is 3, minus 2 root 3 minus another 2 root 3, and then minus 2i times minus 2i is plus 4i squared, which is minus 4. So that is minus 1 minus 4 root 3I. So that is what our fraction looks like. We've got 1 over minus 1 minus 4 root 3I as the thing that we're looking for. But that's not finished, is it? Because the question said, giving your answers in the form x plus iy. And that applied to both parts. So even though we've evaluated it, we found out what it is, we now have to finish this by kind of dealing with the fact that that's not in the form that we want. It's the rationalising the denominator stuff that you do from core 1, isn't it? So we multiply that by the complex conjugate at the bottom. So we now need to multiply by minus 1 plus 4 root 3i top and bottom. And that gives us minus 1 plus 4 root 3i on the top. And on the bottom line, we've got minus 1 times minus 1. And then we'd have minus 4 root 3i plus 4 root 3i. And then we would have a minus 16 times 2, so that's minus 48i squared. Which gives us a plus 48 on the bottom. And the question said, in the form x plus iy. So that's minus 1 over 49 plus 4 root 3 over 49i. And it doesn't give you that warm feeling inside that you've got an obviously right answer, because that's pretty horrific to look at as an answer, but that is what the answer was. So there you go. Maths.